In this experiment, we're going to be looking at the heat content of various types of foods. Basically, you would normally be doing this in what is called a bomb calorimeter, which would be a sealed canister, and you'd fill it with oxygen and your food source and then ignite that with an electric spark. And that would literally blow up the food as it would combust completely in a pure oxygen environment. And you would measure the heat absorbed by the surrounding chamber, which was filled with water. We're doing it on the cheap version. So what we basically have is a setup here on a ring stand where we have a temperature probe that we can drop down into a container that will be holding our water for us as the material that's going to be absorbing it. This can is just an ordinary tin can from vegetables or other kinds of things that you might have at home. We punch some holes in the side and then have a stirring rod that fits through so that it will hold that. We could mass what this is. And right now the mass of the empty can alone has a value of 44.62 on our balance. So I'm going to take a picture of that just for reference, and I'll have that included later on in the data. What we're going to do is we're going to add to that 100 milliliters of water. So you could either measure that volume fairly accurately at 100 milliliters. And since water is 1 gram per milliliter, that should be about 100 grams. But I'm also going to measure the mass. So I'm going to dump that into my can on my balance. Try to get all the drops out. And we initially had a value that was 44.62. This is 142.14. So it's slightly less than 100 grams, but it's close enough for government work because that's what we're doing here. We're doing government work as part of the Science in Motion program. I'm going to put that on a ring stand so that it will now support that. And then we have a stand that we're going to be used to hold our food. This stand is actually just a piece of aluminum foil. That's only to catch some of the particles that might fall off of it. And then what we also have here is a paper clip that has been folded so that now it forms a stand that the food can sit on top of. I'm doing this because of the fact that while I'm burning it, maybe some of the food will fall off and not burn completely and end up at the bottom. So we would have to subtract that from the amount that actually will burn. So this gives me a value of 1.40 as the amount of mass for the aluminum foil plus that of the paper clip that's going to be the support. So again, I will take a picture of that and then record that in my data. The sample that I've selected to be able to work with is a Cheetos, the Tiger Paw. You can use any kind that you have as far as any food source. Some people will burn nuts. I'm a little cautious about that, particularly with peanuts, because of the fact that you may have students that are allergic to that, and heating it up is going to produce some vapors into the atmosphere, and they would then, of course, breathe those and now have an issue. I'm going to take this and I'm going to try to mount it onto my little support that I have here. I'll throw that back on here so I get a mass value of the Cheeto with the paper clip and also the piece of aluminum foil. And I'm recording it for posterity. It's 2.94 as all three of those together. I will now place that over here so that it's directly below the can. I am going to initially light that, so I could use a match or a butane lighter. I have just a lighter that I'm going to use to ignite that. Before I actually light it, what I want to do is I want to get a temperature reading of my water. So I'm going to drop my temperature probe down inside there. And the temperature reading itself can be looked at on this graphical analysis file that we have. If I wanted to, I could blow that up larger so you could see a little bit better. It's 21.8, 21.7 as the initial temperature value. I will just leave it like that so that we could use that for a comparison as we're examining the temperature change that's going to be occurring. And this is in degrees Celsius that we have for our temperature. So I'm ready to start my reaction. I'm going to pull the Cheeto out of the way when I first light it, so I'm not getting flame from my striker actually heating up that water as well. Let me start collecting some data just so I get a baseline of what the temperature was. Let me ignite this and get it starting on fire. And what I can also do is I can lower this down just a little bit, trying to get it so that it's right above the flame. So we're trying to capture the maximum amount of energy that's being produced. Now my temperature probe, I'm going to move it up just a little bit so that it's in the water, but it's not touching the bottom of the can. You can see quite a bit of heat is being generated. Get your fire extinguisher out. Hopefully you don't have any fire alarms that are going to get set off by burning of the fuel. But there's an awful lot of heat that's being generated by this reaction as we work our way through. Oh, you silly goose. The final temperature has risen to about 34.6 degrees. Unfortunately, I did not start collecting data before I began burning it, but I did look at the initial temperature, and that was the value that we had at 21.7, as I recall. So we get the peak difference between those two. You might notice that we have a little bit of charcoal or ash left over from our Cheeto that did not burn completely. So what we need to do is we need to mass what's left as far as that Cheeto goes, along with the paper clip, and taking a look at the piece of aluminum foil. It is now 1.57 grams. And we want to subtract that ash that's left over from the original amount so we know how much was actually burned in the process. So now you have the data for the mass of the water that was heated up. Water has a specific heat, about 4.18 joules are required to cause 1 gram of water to go up by 1 degree Celsius. We know the mass of the water that we are heating up, which is roughly about 100 grams. And we know the change in temperature that has occurred in our process so that we can take a look at the difference between those two from our initial to our final temperature, our final peak temperature that we reached in terms of the process. So now it's just a matter of calculating the amount of energy that's being generated. We will need to consider sources of error. This is not completely efficient due to the fact that some of the heat is going to the surroundings and not going into the can and the water. The can itself is absorbing some heat, so not all of the energy is going into the water itself, but it's a good way to do a comparison between various types of foods. We can check the back of the product that you're working with, whatever it is, and they will tell you what's the percent of fat and percent of total saturated fat in there as well. So you would assume that more fat creates more energy in the process. So that's it. We will take a look at the results you come up with and see how close we are to the accepted value, looking at the